So we did everything in a kind of idealized way so far, but obviously we have to start adding reality. What are the complicating factors? As I already mentioned once, eventually there are some 400 factors that affect real tides. We are obviously not going to look at all of them, but we'll look at some of the most important ones, let's say. Okay, so declination of the moon. That's the angular distance of the moon or sun above or below the Earth's equator, right? When we did the idealized tides, we made the Earth stand up like this with pole to pole axis going vertical, and we put the moon and the sun on the equatorial plane. Now it's time to move them to where they really are in the real world, right? We already know that the Earth is tilted at 23.5 degrees to the plane of the ecliptic around the sun, and it turns out that moon is declination of the moon, decline, not wrong word. The declination of the moon is 5 degrees with respect to the equatorial plane of the Earth. So you're going to end up with 23.5 plus 5 and then minus 23.5 plus 5. So the full range of the declination of the moon will turn out to be 28.5 degrees north and south of the equator, which means these nice bulges we showed on either side of the Earth is not going to be valid anymore. And if we still stick to the aquaplanet and assume all the continents are sunk and only water is being forced by the tidal forces, then we will just move the bulges to align with the moon's position, right? So the lunar and solar bulges are going to shift from the equator, and they were going to begin to produce unequal tides. So this is how it's going to work. So here is moon at its top position of 28.5 degrees to the equatorial plane, and there is the North Pole, and the tidal bulge is going to shift to align with the moon because we are still considering idealized tides with no bottom friction and no continents affecting the movement of the tides, or the bulges are shifted and the Earth is now going through the bulges at an angle. So you're going to end up with unequal tides, but you still have tidal bulges on the other side. It's just that they are now at an angle. So the other complicating factors are we are in an elliptic orbit, Earth around the Sun. So the distance of the Earth itself from the Sun changes by season, as we know. So when it is closer to the Sun in January, as we said before, our winters in the northern hemisphere are milder because you're a little bit closer by a few million miles to the sun in January, and you are away from the sun at the aphelion in July. So perihelion is the closest point to the sun, aphelion is the farthest point from the sun. So that's another complicating factor because the solar tidal forces are going to depend on the change in the distance. And remember, tidal forces are 1 over r cubed. So that's going to make a difference. The other complicating factor, moon around the Earth. Moon itself also has a non-circular orbit. So when moon is closest to the Earth, it's called perigee. Perihelion, sun, perigee, moon, aphelion, sun, apogee, moon, right? So perigee and apogee cycle is 27.5 days. This is different from the time that the moon takes to go around the Earth at 29.5 days. This is the cycle from the perigee to apogee and back. So the perigee to apogee cycle is 27.5 days. Do you need to worry about it? It's good to remember, but just decide what you might end up doing in the end with the tides anyways, right? But good to know these things. So Proxygean tides occur when you have a spring tide. So the constructive interference between the lunar forcing and the solar forcing, and moon is at its closest point to Earth. So spring tide plus perigee is going to give you something called the Proxigean tide. So you get exceptionally high tidal range. Spring tide is already the high tide, the strongest tidal range. Then the moon is going to get closer, so you have a constructive interference when the moon is closer, so you're going to have very strong tides, Proxigean tides, and this only happens about every 1.5 year or so. Okay, so here is the figure. You have apogee when the moon is away from farthest point from the Earth. Perigee is when moon is at its closest point to the sun in its elliptical orbit around the Earth. And then you have aphelion when Earth is at the farthest point from the sun in its orbit around the moon. And perihelion when it is closest to the sun in its orbit around the sun. So we are just adding simple things, but as always, as I said before, 1 + 1. You need to carry these things in your mind. They're not complicated, but if you just look at these podcasts a few times, it's probably going to get imprinted in your head, so you don't need figures. Then you can just explain everything to grandma by just showing her the sky and tell her how things move, right? Why do I say explain to grandma? Because unless you understood it very well, you probably cannot explain it to grandma very well, because if you seem to be saying something that doesn't make sense, grandma is going to ask you questions and you are going to get stuck. So make sure you understand well enough to explain to grandma.